I was driving the other day and I saw this kid, couldn't have been more than maybe 3 or 4, just standing on the sidewalk, refusing to move.
Oh, yeah?
And the parent was pleading, please, we have to go. And the kid just kept shouting one word back, why? It went on for like 5 minutes. Put on your coat. Why? Because it's cold. Why? And it struck me that this is basically the operating system of the human brain. We are just obsessed with cause and effect.
It is. It's the fundamental glue of our reality. I mean, we can't really function without it. If you touch a hot stove, you need to know why your hand hurts, or you're going to do it again.
Right.
It's the bedrock of logic, of narrative, of survival itself.
Exactly. And because it feels so natural to us, it's just intuitive, we assume it should be easy for our technology to understand, too. We figure, hey, we have ChatGPT, we have Google Translate, computers must know how why works. But I was reading through this stack of research you sent over, and it turns out teaching a machine to understand causality is actually incredibly difficult.
Hmm.
And it gets exponentially harder depending on which language you're trying to teach it in.
And that is the perfect setup for today's deep dive.
Wow.
We are looking at a really fascinating piece of research that comes to us from the AU KBC Research Center in Chennai, India. The paper is titled Automatic Identification of Cause-Effect Relations in Tamil Using CRFs.
Which, I will admit, sounds a bit like alphabet soup at first glance.
It does, but the implications are huge.
Yeah.
The researchers Minaka S., Patabi R.K. Rao, and Sobha Lalitha Devi, they aren't just trying to solve a coding problem. They're grappling with how we map human logic onto a digital brain.
Okay.
Their mission was to build a model that can read text in Tamil and figure out, okay, event A happened, the cause, and because of that, event B happened.
And what I found so gripping about this is that it exposes a blind spot. We tend to think that because AI works in English, we've sort of solved language. But this paper proves that when you switch to a language with a completely different architecture, like Tamil, the tools we built for English
They break.
They just break.
They crumble. And to understand why, you have to look at the source code of the language itself.
Yeah.
Tamil is structurally very different from English. It's what linguists call an agglutinative language.
Agglutinative.
Yeah.
I love that word. It sounds sticky.
It literally means gluing together from Latin. So think about how English works. It's like a set of Lego bricks. If I want to say because of the rain, I grab 4 separate bricks. Because of the rain,
Right.
I line them up in a row. They're distinct, separate units.
Right. Linear and separated.
In an agglutinative language like Tamil, you don't line up separate bricks. You take the brick for rain and you sort of mold the concept of because directly onto it as a suffix. You are gluing grammatical markers onto the root words to create these long, complex meaning chains.
So rain because becomes a single entity.
Essentially, yes. But here is where it gets tricky for the AI, because these tags, these sticky suffixes, tell you exactly what role a word plays in the sentence. Tamil doesn't need to rely on strict word order like English does.
English is so stiff about order. The dog bit the man is a news story. The man bit the dog is a viral video.
Yes.
The order defines who did what.
Precisely. But in Tamil, the word for dog would have a specific tag saying, I am the subject, and man has a tag saying, I am the object. Because those tags are glued to the words, you can move them anywhere in the sentence. You can put the object first, the subject last, or shuffle them around, what linguists call scrambling, and the meaning remains 100% clear to a human listener.
But I'm guessing that scrambling drives a computer absolutely crazy.
It's a nightmare. I mean, most of our AI history is built on English-centric models that rely on proximity. They assume cause usually comes before effect, or that the word because will be sitting right next to the reason. In Tamil, the cause could be at the start of the sentence, the effect at the very end, and the word for because is a suffix glued onto a word somewhere in the middle.
And everything in between is just shuffled like a deck of cards.
Exactly.
So the researchers couldn't just download a standard English dataset and hit run.
No. And that was their first big hurdle. For English, we have these massive, pristine databases like the Penn Discourse tree bank, where thousands of sentences are already tagged with cause and effect. Tamil didn't have a resource like that for this specific task, so Minaka and her team had to build their own.
And I really respected their choice of source material here. They didn't use technical manuals or, dry news reports. They used a novel.
Yes, Akal Vilaku by Mu Varatarajan.
Which seems like a bold move. I mean, fiction is messy. It's got dialogue, slang, weird metaphors. Why make it harder on themselves?
Well, because if you want an AI to understand humans, you can't train it on toaster instruction manuals. You need the messiness of real speech.
Good point.
They manually went through this book and annotated 8,648 sentences.
That is a staggering amount of reading.
It's a labor of love. They had to manually tag every single instance where the text claimed one thing caused another, and we should probably clarify, they weren't checking for scientific accuracy.
Right, right. They aren't fact-checking physics or anything.
Correct. If a character says, "My heart broke because she left," the AI needs to tag that as a cause and effect. It doesn't matter that hearts don't literally break. They're looking for event 1, the cause, and event 2, the effect.
They're teaching the machine reading comprehension, not science.
Exactly.
Okay, so we have the messy data from the novel. Now we need the detective.
Yeah.
How do they actually teach the machine to find these needles in the haystack?
They start with what they call linguistic cues. These are the red flags that wave at the computer and say,
Yeah.
hey, pay attention. There's a reason and a result happening here.
Like finding fingerprints at a crime scene.
Exactly. In English, we look for standalone words like because, since, or therefore. In Tamil, as we mentioned, these are often suffixes. The paper lists a few critical ones. There's aal, or innal, which usually attach to a noun phrase, or atal, which attaches to a verb.
Let's look at the example they give in the paper, just to make this concrete for you listening. They use the sentence, because the wind blew, the papers flew. In Tamil, karu atidal kakitankal parantana.
Right, so break that down. Karu atitatu is the root for wind blew. That's the cause.
Okay.
Kakitankal panantana means papers flew. That's the effect. But look at that first part again. Karu atitatal. That little al at the very end.
That's the marker.
That is the smoking gun. That's the marker. It tells the reader, because this happened.
So the computer scans the text, hunting for that specific suffix. It sees ahal and thinks, aha, we have a potential causal relation.
Exactly. It also looks for lexical markers. Standalone words like kuranam, which literally means reason, or akayal, which means therefore. So that's step 1. Find the marker. That's the relatively easy part.
And step 2 is where the brain damage starts.
Step 2 is determining the arguments. Okay, you found the suffix. Now, tell me exactly which words in this sentence describe the cause and which words describe the effect. Where does the thought start and where does it stop?
To do this, they use the tech stack mentioned in the title, CRFs, or conditional random fields. Now, I've seen this term thrown around in machine learning, but usually my eyes just glaze over. Can we break this down without a whiteboard?
Let's try. Think of it this way. Simple AI follows strict rules. If you see X, do Y. But language is too fluid for strict rules. CRFs are about probability and sequence. They treat a sentence like a chain of events or a path you're walking down.
Dominoes falling.
In a way, the key is that the model makes what's called a first-order Markov independence assumption.
Okay, hold on. That sounds like Star Trek technobabble. Captain, the Markov assumption is failing.
It does, doesn't it? But the concept is actually very relatable. It just means the model has a very short-term memory. It assumes that the identity of the current word depends heavily on the tag of the word that came immediately before it.
So it's moving through the sentence, predicting the label of the current word based on the context of what it just saw.
Yes. It's reading left to right, thinking, okay, the last word was a noun, so there's a 90% chance this next word is a verb, that kind of thing.
Got it.
Precisely. But the researchers can feed it extra clues. They can tell the CRF, hey, in Tamil, if you see the suffix al, the words immediately preceding it are usually the cause. The CRF takes those rules, combines them with the probabilities it learns from reading the novel thousands of times, and tries to label every single word in the sentence.
And they did something interesting here with the labeling logic. In English systems, they often rely on syntax, the grammar tree. But the Tamil team went purely semantic.
Yes, this is a crucial distinction. They decided the cause is always tagged as argument 1. The effect is always tagged as argument 2.
Regardless of order.
It doesn't matter where they sit in the sentence. They are tagging the meaning, not just the grammar structure. They are trying to teach the computer to understand the role of the text, not just its position.
So they built the data set. They trained the CRF model on this novel.
Yeah.
How did it do? Did it crack the code of Akalvalaku?
Well, the results were very illuminating. And not just because they were good, but because of where they failed.
Give me the numbers.
Stage 1, finding the marker, the because suffix, was a home run. 92% accuracy.
Solid. So it knows that a reason is being given.
But stage 2, identifying exactly what the reason was and what the result was, that dropped to an F measure of around 75%.
So 1 out of 4 times, it's getting the boundaries wrong. It's chopping off the sentence too early or letting it run too long.
This is the aha moment of the entire deep dive. When they audited those errors, they found something that basically explains why translation software struggles with Indian languages. They call it structural interdependencies.
Which sounds dry, but the examples in the paper are wild. They found patterns that I don't think even exist in English, or if they do, we rarely use them.
Oh, they exist in English, but they are clunky and rare. In Tamil, they are standard features. The researchers categorized these problem areas into 3 types. Let's walk through them because they really show the geometry of the language. The first is embedding.
This is what I was calling the Matryoshka doll problem.
Yes. In English, we like linear chains, cause-marker effect. He fell cause because marker he slipped effect.
Or because he slipped, he fell.
Right. They are separate blocks like train cars hooked together.
Block A, then block B.
In Tamil, the grammar allows you to take the cause and physically stuff it inside the effect clause.
Whoa. Give me an example of that.
Okay, there's a sentence in the text, "Father was suffering because of boils on his back." In the English translation, that's linear. But in the Tamil structure, the phrase "because of boils" is actually tucked inside the phrase describing the father's suffering.
Wait, so it's not 2 train cars.
It's a box inside a box.
So the computer starts reading the effect, father was suffering, then suddenly hits the cause, boils, and then goes back to the effect.
Yes. And the CRF model, which is reading sequentially, remember that domino effect? It freaks out. It thinks, wait, I was tracking the father. Why am I suddenly looking at boils? Did the father sentence end? It can't handle the nesting. It assumes that once a new segment starts, the old one must be finished.
It's trying to draw a straight line, but the sentence is a circle.
Exactly. And if you think that's confusing, wait until you get to the sandwich.
I love that they call it that in the technical analysis, the sandwich.
It's the perfect visual. The sandwich is when you have a cause and effect relationship, let's call it story A, and right in the middle of it, the author drops a completely independent cause and effect relationship story B.
So you're telling a story, and you interrupt yourself to explain a subplot, and then you finish the main story.
Yes. There's a great example from the novel involving a character named Chandran running away from a college hostel. The text is explaining why he ran away. That's the bun of the sandwich. But the meat in the middle is a side story about how a girl named Imavati cheated him.
Okay, let me visualize this. So Chandran ran away, start of effect A, because Imavati cheated him, cause B, which made him angry, effect B, so he left the hostel, end of effect A.
Precisely. Now imagine being the computer. You're tracking Chandran's location. Suddenly, you're processing Imavati's betrayal. The CRF model just breaks the chain. It assumes proximity equals relevance.
It loses the plot.
Literally, it cannot see the hierarchy. It treats all text as flat.
And there was a third pattern too, right? The crisscross.
They call it interleaving. This is the loom analogy. Imagine you have cause A and cause B, and then effect A and effect B. In English, we'd say, because of rain, the grass is wet, and because of sun, the flowers bloomed. Tidy.
Group A with A and B with B.
Tamil allows them to be interwoven in a single complex sentence. The example in the paper compares discipline in Western countries versus the absence of discipline here in India. The text presents the reasons for both places and the results for both places, tangled together in one long thread.
So the machine has to act like a loom, weaving these threads apart to figure out which cause goes with which effect.
And remember, the machine is using that Markov assumption. It mostly looks at the neighbor, but in an interleaved sentence, the neighbor might belong to a totally different topic.
This really highlights why we can't just take an English AI architecture and swap the dictionary. The geometry of the thinking is different.
That is a great way to put it. The geometry is different, and there are even simpler things that trip it up, specifically ambiguity.
Oh, the reported speech problem. I spent some time staring at this one because it happens in human conversation constantly.
The example is, I said that I went because you asked.
I said that I went because you asked.
Okay, now stop and think. Did you go because I asked, or did you say it because I asked?
Oh, I see. It could be, I went because you asked, or it could be, I said because you asked that I went.
Right. The phrase because you asked is just floating. It could attach to the verb went or the verb said.
How do we humans figure that out? I feel like I'd know what you meant if you said it to me.
We use context and what linguists call selectional restrictions. We know that asking usually leads to an action like going.
Hmm.
We weigh the probabilities based on real-world logic.
Yeah,
We know that people usually need a reason to go somewhere, but they might not need a reason to say they went.
but the CRF model.
It just sees two verbs, said and went. It doesn't have the common sense layer to know that asking usually triggers action. It sees two viable parents for the orphan clause and often picks the wrong one based on simple distance.
It's missing the world model. It knows language, but it doesn't know life.
Perfectly put. And finally, there is the issue of shared arguments. This is where one event pulls a double shift.
The pivot point.
Yes. There's a chain in the text. Income reduced, leading to horses not maintained well, leading to horses look ugly.
Okay. Income drop, bad maintenance, ugly horses.
Look at the middle part. Horses not maintained well. Is that a cause or an effect?
Well, it's the effect of the income dropping, but it's the cause of the horses looking ugly.
It's both, simultaneously.
Yeah.
It is the effect of chain 1 and the cause of chain 2.
Does the machine hate that?
It hates it. Most classification models want an item to belong to one category. Is this a cat or a dog? It struggles when the answer is, it is a cat to the person on the left and a dog to the person on the right.
The machine wants to put the text in one box, but the narrative flow requires it to be in two boxes at once. So when you look at all these hurdles, the matryoshka embedding, the sandwiches, the ambiguity, what's the verdict? Did Menaka and her team succeed?
They made a significant first step. I mean, getting 75% accuracy on identifying full arguments in a literary text with free word order is actually quite impressive for a CRF model. But the paper is arguably more valuable for the problems it identified than the ones it solved.
It's a map of the minefield.
Exactly. They conclude that discourse complexity in Tamil is significantly higher than in English for these specific tasks. And their recommendation is that we can't use a one-size-fits-all cause detector.
What do they suggest instead?
They suggest specific models for specific markers. You shouldn't treat the suffix "-all" the same way you treat the word karanam. They behave differently structurally. You need tailor-made tools for each linguistic quirk.
It's like saying you can't just have a screwdriver. You need a Phillips, a flathead, and a hex key, because the screws are different.
And you have to know which one to use without asking.
This makes me look at AI translation so differently. We tend to think of it as word swapping, apple equals palm, but it's really about thought swapping.
It is, and it brings up a fairly profound question that linguists have debated for a century: the Sapir-Whorf hypothesis.
That's the idea that the language you speak determines the way you think.
Weak versions of it, at least. If your language, like Tamil, allows you to naturally nest causes inside effects, or interleave two stories into one sentence, does that mean a Tamil speaker processes causality differently than an English speaker?
That is a trip. Do they see the interconnectedness of events more intuitively because their grammar literally wraps one event inside another?
It's possible. In English, we segregate events. A, then B. In Tamil, A is inside B. That might reflect a more holistic view of the world. And if we want AI to truly understand that worldview, it can't just be a linear English brain wearing a Tamil mask.
It has to learn to see the sandwich.
It has to learn to see the sandwich.
I love that. It's a humbling reminder that for all our tech, language is still this wild, ancient, messy thing that refuses to be easily digitized.
And that's what makes it fun.
Absolutely. Something to mull over the next time you ask why. Thanks for listening to this deep dive into the architecture of Tamil.
Pleasure being here.
We'll catch you on the next one.